Hi to all, this is Vendan Doraisamy. Today we are going to see another important algorithm in OS operating system, disk scheduling and management concepts. Already we discussed about CPU scheduling algorithms and page replacement algorithm. Today we are going to see the next topic, disk scheduling algorithms. So in disk scheduling, two basic concepts we must know. First one is seek time. Consider this is a disk. This disk is divided into different circular shapes. They are called as tracks. For example, here we are having 1, 2, 3, 4 tracks. So the time needed to move from one track to another track is called as seek time. For example, if you want to move from track 4 to track 1, that time calculated is called as seek time. And the next one is rotational latency. So rotational latency means inside a track it is divided into different sectors. So the time needed to move from, for example, I am in track 4 sector 1, the time needed to move from sector 1 to sector 3 in that particular track, that time is called as rotational latency. So we must know these two basic concepts. A seek time, that is the time needed to travel from one track to another track. Then rotational latency is the time needed to move from one sector to another sector in the same track. So this is the formula to calculate. After discussing the problem, we will come to this formula. So these are the different algorithms we can use to solve this disk scheduling problem. So the first one is first come first serve. Already we discussed about this concept in CPU scheduling algorithms, page replacement algorithm. Then the second one is shortest seek time first. It is same like a shortest job scheduling algorithm. And the third one, scan and circular scan. And 5 and 6 look and see look algorithms. They are same as scan and see look, see scan, but there is a slight difference. We will discuss during that discussion of the algorithms. So first the problems will be given like this. There will be different, consider there is a, consider hard disk. The files are placed at different memory locations, like these are all the different memory locations of the file, and the initial head pointer now it is in a particular position, and this is the Q value. For example, if the problem is given from 14 and the highest value is 183, and if the Q value is not given, we have to consider the lowest value as 0 and the highest value as 199. If for example instead of 183, if the value is 283, then we have to consider the highest value as 299. But in a problem normally these three inputs will be given, the request Q value, lowest value and the highest range value, and the different input values and the initial head point position. Now the initial head pointer it is in the location 53. So first come first serve algorithm, directly we get into the problem. So these are all the initial lowest value and highest values 0 to 199, and this is the initial head position value 53. So based on the input we are going to solve the problem. The first input is 98. So from 53 we are moving to the first input value 98. After 98 the next input value is 183. From this location we are moving to this 183 location. Likewise for each input we have to solve, or we have to go through all the inputs based on the input order. The last input it is 67. So this is the value for 65, and from 65 to we are moving to 67. So likewise based on the input first in first out we have to visit all the values. Then we have to calculate the head movement value. For calculating the total head movement value, initially it was at 53, then we have to move to 98, after that 183. So we have to take the difference between the two values. So the first head position it is at 53, then the next point it is at 98. So we have to take the difference between these two values, and be careful, we should not take this value as minus 45. We have to only take the difference between, when you are doing the coding we have to use that absolute function to get the positive value. So the difference between 98 and 53 it has to be 45 only, it should not be minus 45. So just don't follow the basic subtraction formula. Here we are going to take the difference between these two values. Likewise we have to find out the difference between all the two different locations, then we have to sum up the total value. So if we follow first come first serve algorithm. For this input, the total head movement is going to be 640 cylinders. Cylinders is the unit value. And the next algorithm is shortest seek time first. So in shortest seek time first, the same concept we are going to follow, but from the current position we have to consider which is the next nearest position. So that is the concept begin shortest seek time first. For example, yes, we are having the same input, and the initial head position it is at 53. Okay, then we have to consider the values on the left and the values on the right, and which is having the minimum distance we have to cover that particular value. For example, the distance between here to here it is 12, but the difference between 53 and 37 the value is 16. So the nearest value it is going to be 12. So from 53 I am going to 65, and from 65 we have to consider the next value is 67, which is 2, and between 65 to 37 we have to take the difference value, which is going to be 28. So the difference between 2 and 28, so 2 is the smallest value. So we have to move from 65 to we have to move to 67. Likewise, we have to consider from the current location, from then we have to consider which are all the remaining points. From that points which is having the minimum distance, that distance point value only we have to access the next one. For example, now we are in 67. The left pointer it is at the location 37, and the right pointer which is at the location 98. So the difference between 67 minus 37, the value is 30, but the difference between 67 and 98, the value is going to be 31. So 30 is going to be the minimum value. So from 65 we have to move to 37. We should not move to 98. The reason is that here 30 is the shortest seek time. So based on the seek time difference value which is having the minimum shortest seek time, we have to take that particular value. Then from 37 again we have to consider 14 and 98. Obviously 14 is going to be the smallest value. Then we are visiting 14. After that, yes, then all the values on the left hand side it is completed. So we are starting at 53, then we gone to 65, 67, 35 and 14. There is no value on the left hand side. All the next head point positions is on the right hand side. So we are visiting all the values one by one until the last value, that is 183. Then what we followed in the previous algorithm, first come first serve, we have to take the difference between the two values. Then we have to calculate the total value. So the total here head movement value it is going to be 236 cylinders. If we take again, we have to be very careful. We should not consider this value as minus 2. This is only a positive value plus 2. So that is we have to write here. The third algorithm it is going to be scan algorithm, or it can be called as elevator algorithm. Why the reason we are calling it as elevator means because elevator will move from one direction to another direction. Once if it reaches the opposite direction, then automatically it will reverse the direction. So that is the concept behind elevator algorithm. The same concept only here also we are going to use it in scan algorithm. But here we need additional one input. We must know the direction of the head movement, because for the previous two algorithms we are given the initial head position as 53. Here we need another one input, that is we must know the direction of the head movement. For example, we have mentioned it is moving towards 0. So the initial head position, for example 0 to 199. Now the initial head position it is in 53, but here we have given additional input, it is moving towards 0 means first from 53 we have to move towards the left direction, or if they given the value is moving towards 199, from the initial head position we have to move towards 199, or else sometimes the input can be mentioned as directly moving towards left side or moving towards right side. So that input also we have to consider for this scan algorithm. Along with the head position we have to have this whether in which direction we are going to move from the current head position. So the values can be given as moving towards 0 or moving towards 199, or explicitly it can be given as moving towards left direction or moving towards the right direction. So here the initial head position is again the same input we are having. The initial head position starts at 53, and the previous slide itself it has mentioned as we are moving towards the direction 0. So from 53 we are moving towards the direction 0. Okay. So we are not going to consider the smallest which is having the smallest next value. Likewise, we are not going to take the difference from the current position. We are moving towards the left direction. So whatever the request during that left direction, moving towards left direction, we have to proceed all the request. So from 53, this is the left direction. First request is at 37. Then we are moving towards 14. Then towards 0. Once if it reaches the either one of the side. For example, we have reached the left side 0, then automatically we have to move towards the right side. For or in the case if we are moving towards right side, if we start from 53, so initial 65, 67, likewise once if we reach 199 the right hand direction, if this is the end, then automatically it will reverse its direction. But for this problem, the initial condition was given as we are moving towards the left direction. So from 53, we have processed all the requests on the left hand side. And once if it resets 0, then automatically we are moving towards the right direction and we are processing all the elements. For example, after 53, 65 is the next request. So we are moving towards 65. Then based on the next input value 67, 98, we have to process all the inputs, and the last one is 183. So once if all the inputs are completed, again we have to take the differences between the values and we have to calculate the sum of the total head movement. Here the value is going to be 236 cylinders. For example, after this we are having, or instead of calculating for all the values, here it is very simple. For example, we can take the difference between 53 minus 0, 53. For example, 53 we have started at 53 and we are moving towards the left direction value is 0. Then from 0 to we are moving towards 183. So directly we can calculate the value is going to be 236. Once if you are clear and if you are thorough with the concept, instead of taking the differences between two values, we start at 53, we have reached 0. So the difference between this and from 0 to 183, where the total head moment value is going to be same like what we have calculated here. So this is the idea behind this scan algorithm. So what is going to be the difference between scan and circular scan algorithm? As the name suggests itself, it is circular scan. So the same concept we are going to take, but here we have moving towards, here the condition, the next input along with the initial head position, the next input here you can see we are moving towards the larger cylinder numbers. So for the previous algorithm, we explicitly mentioned we are moving towards 0, but here we mentioned as we are moving towards the larger cylinder number. That means we are moving towards the right side. So these are the keywords we have to be very thorough. Sometimes it can be given as we are moving towards the right side or we are moving towards 199. Here there is another key value called as we are moving towards larger cylinder, that is we are moving towards the right direction. So initially we are starting with 53. So while moving towards the right direction, we are requesting or we are processing what are the requests in between 53 to 183. So 65, 67, 98, and this is 183, and this is 199. So it is the concept of elevator algorithm. Once if it reaches the one end, automatically it will move towards the other end. But in scan algorithm, while returning, we have processed all the inputs, but this is circular scan algorithm. C stands for circular scan algorithm. So if it reaches one end, while returning, it does not process any request. Again reaching the other end 0, then it has to change its direction towards the right side. So while moving towards the right side only, it will process the request of 14 and 37. So this is the idea behind, or this is the difference between scan and circular scan algorithm. If it is scan algorithm, again if you are reaching 199, if we reach 199, while returning we will process this 37 and 14 and we stop the process here, if it is a scan algorithm. But this is a circular scan algorithm. So while returning, it does not process any request, then it reaches the direction 0. From 0 again it will move towards the larger side of the cylinder value. So while moving towards the larger side only, it will process the remaining two requests, that is 14 and 37. Then as usual we have to calculate the difference values, where the total head movement it is going to be 382 cylinders. or simple we have to calculate from the difference between 199 minus 53, then again 199 minus 0, then 37 minus 0. So 37, 199. If we sum up all these values, we will get this value 382 cylinders. So until you become expert with this problem, you take the differences, just to take the differences and sum up all the values. So the next two algorithms, Cloook and Cloook, they are all the extension of this scan and C-scan algorithm. Again, for Cloook and Cloook also, we have to give the direction, that is we are moving towards 0, that means we are moving towards the left side direction, or if it is moving towards 199 means we are moving towards the right side direction. But this is an extension of this scan and C-scan algorithm. Now we will see how this Cloook and Cloook algorithm, they are different from this scan and C-scan algorithm. So again, the initial get position, it is at 53 and we are moving towards 0, that means we are moving towards the left side direction. So while moving towards the left side direction, we have to process the request. The first request is at 37 and the next request is at 14. But in scan algorithm, we reached this n value 0. After reaching 0 only, we moved towards the right side direction. But this is Cloook algorithm, which is an extension of scan algorithm, which is the last request on the left hand side. We have to stop with that request. We do not need to move to the last value 0, that is the n value 0. This is the last request on the left hand side direction. So we are stopping with 14. Then automatically the direction will be reversed. While moving towards the right side, we have to process all the requests. So the next request is at 65, 67. Likewise, we have to process, and the last request is 183. So the difference between scan and Cloook algorithm is that we are moving towards the left hand side, but in scan algorithm we have reached 0. We have to reach 0. From after reaching 0 only we moved towards the right hand side. But here in Cloook algorithm, after reaching the last value on the left hand side, that is 14, we have to move towards the right hand side and we have to process the remaining request, and finally we have to calculate the sum value. For example, the difference between these two is 14 to 0 and 0 to 14 is 28. So in scan algorithm, we have the total head movement of 236, and here we are having, that is we have to subtract the value minus 28. So we have a total head movement of 208 cylinders. From 14 to 0 and 0 to 14, these values we need not to add. If it is scan algorithm, we have to reach 0, but if it is Cloook algorithm, we have to stop with the left hand side value, last value 14. For example, we are moving towards the right hand side. So from 53, we have to reach up to 183. We have to process all the inputs 67, 67, 98, 122, 124. Then 183 is the last value. Then we need not to go up to 199. Automatically we have to reverse and we have to process this 37 and 14, then we have to stop. Okay. But if it is scan algorithm, here additional we have to go up to 199, then we have to return. So that is the difference between scan algorithm and Cloook algorithm. And the last one is Cloook algorithm, which is an extension of C-scan algorithm. So we all know that in C-scan, we have to start at the particular head movement, then based on the direction we have to move either left or right. Then if we reaches the one end, while returning we will not process any request. If we are processing, that comes under scan Cloook algorithm, and while returning we should not process any request. So this is the concept behind Cloook algorithm and Cloook algorithm. So again we are starting with 53 and here we are moving towards right side value. So we are moving towards right side value, that is we are moving towards 199. So this is the last request 183. We should not go up to 199. If it is C-scan algorithm, then we have to reach up to 199. After that only we have to return. But this is Cloook. So we have to stop with the last request value, and while returning to the left hand side, it should not process any request. And 14, this is the last value. So we are processing the request value 14 and we are moving towards the right hand side value. For example, you can see in scan algorithm, we have gone up to 199 and we have come to 0, then moving towards the right hand side only we have processed. This is C scan, but in C look, so which is the last value on the right hand side, we have to stop with that value, we should not move up to 199. Then we are returning towards the left hand side, so 0 we should not go up to 0, we have to stop with the last request value, that is 14, and while requesting and the returning on the right hand side, we have to process the remaining request 37. So then we have to calculate the total head movement value, that is 328 is the total head movement value. In C scan algorithm, we are having a total head movement value of 382. So once if you understand this concept, 382 in C scan, in C look it is 322. So if we take the differences, here already we know, for example in the right hand side, this is the difference value 16, 16, while moving from 183 to 169, 199, and from 199 to 183, so 32. Likewise here there is a difference of 28 from 14 to 0 and 0 to 14, and if we sum up these values, 28 plus 32 which is 60. So we have to subtract the value 60 from 382, that is from C scan, we will get the total head movement value of 322 cylinders. So these are all the different algorithms that comes under disk scheduling algorithms. So these are very important. For example, in a room we are having different objects at different locations, different places. We have to find out an algorithm, which algorithm will cover the minimum distance that will cover all the objects in that room. For that a real time application, or we can use this algorithmic concepts to find out which will give the total head movement, which will give the minimum total head movement value. That means we can save our time and we can concentrate on the remaining works. These are the different input values: 82, 170, 43, 140, 24, 16, 119, and the initial head movement it is 50. So for the first two algorithms we need only the initial head position value alone. For the remaining 4 algorithms, for scan, C scan, look and C look, C stands for circular, we need in which direction from the current head position towards, either we are moving towards the left side, or we are moving towards 0, or we are moving towards the larger value, or we are moving towards the right hand side value. Likewise, we have to give another input value for the processing of the remaining 4 algorithms. We will come with another algorithm in the next class. Thanks to all.